Hello and welcome to the webinar. So today we're going to be talking about idea to production, how to deploy your own custom app in 48 hours. This is a subject that really just a few months ago would have seemed completely unreal and unbelievable. And now it's actually a reality so long as you understand a few certain things. So I'm joined today by Kane Hooper. Kane is, of course, the COO of Reinteractive. However, Kane, by way of introduction, in case people don't know you, there's probably a few more things that people should know about you, in particular your history and education with regards to machine learning and AI. Do you want to go through a couple of those things?
Yeah, of course, no worries. I've been working on AI. Well, I started my work with AI probably when I was about 10 years old, back in the day when I had an old, very low-powered IBM computer, and the first sort of AI chatbot. It wasn't AI, but you could have a conversation with the computer, and it all just worked on declarative loops. So if you said hello, it would say an exact thing, but it was the first step at trying to turn or to humanize technology, and I was fascinated at that time. So over the years, I've been working in technology for a long, long time. But in the last 10 years, things started to get a lot more interesting. So we built Reinteractive, and I architected a machine learning tooling using just straight statistical mathematics in the way we were building machine learning 10 years ago for a finance client, which was projecting revenue and projecting expenses. So it's like an accounting style application. We've moved into then with the New South Wales State Library, we helped them build out their Amplify product. So they've got 50 years of oral history, so where they've recordings and interviews of local people, whether that's native people, whether that's with the Aboriginals, whether that's people who were coming to Australia, immigrants and so forth, and they were losing that data. So we built an application that would transcribe the text, and at that time, getting it to about an 80% success rate was quite a win. And from there was the human intervention of validating, which became a community project, which is really fascinating. But in the last 3 years, of course, with the introduction of ChatGPT, I've gone all in on AI. I was in the middle of doing a master's of applied AI, but I dropped it because the university could not keep up with the advancements and what was changing. So that's another story. But when I saw ChatGPT and I saw here the real, I would say, advent of humanized AI, where a human, any person could now interact with an AI agent to get things done. And since that time, I've been constantly working on the cutting edge. How can we push the frontier? How can we get the most out of these AI agents? And I would say in the last 3 months, we've had an absolutely incredible. There's my daughter. Hello.
Bye, Kelly.
Bye, mate. The joys of working from home. In the last 3 months, we've had such an incredible paradigm shift. It's like we've hit a critical mass almost, where the models themselves, the AI models, they're definitely getting better. But what the major shift is the tying it all together from an agent perspective, where a whole orchestrated platform can take the large language model to do the reasoning, but now you've got tooling to, whether it's to read code files, it's tooling to go and run things on the internet, it's tooling that performs many actions that makes the large language models exceedingly more valuable. And we have entered in the last few months, well, I've been working on this for the past 3 years, how to get agents to code at an extremely high level of quality and security. The technology's now got to a point where we can build the whole coding orchestrator, still requiring technical review and intervention, but it's at a level now where, and I'm running experiments on this, where well-run agents can code at about 5 times the speed of a single developer. So one developer can increase their speed by about 5x while maintaining high levels of security, high quality code, and importantly, without all the AI slop. So that's what I've been working on. In the last week in particular, I've solved and cracked a few problems that, at least publicly, haven't been solved before, and it's pushing our AI agents to a whole new level of ability, I guess.
Let's just, for the listeners, Kane, let's just lay out where we've come probably in the last 12 months. So a year and a half ago, let's say a piece of development work that would have taken, let's say maybe 6 weeks of development to do by a developer, a skilled developer with a project manager. Let's say it took 6 weeks. Now, around the middle of last year, using AI tools, we can improve the efficiency of that by about 20%, maybe a little bit more for some types of applications, maybe a little bit less for others, but about 20%. And that was pretty much across the board. Like, I spoke to a lot of developers that time, as I think you did, Kane, and we found that was pretty broadly true. People who are skilled and using those tools like GitHub's Copilot, for example, were able to achieve those benefits. Now, that changed, I think, around December. And it's been rapidly changing from that point onwards, from that 20, maybe 30% up to 90, 95%. The skill level the skill set required to do that development has changed dramatically. So a piece of work that would take 6 weeks can now maybe be done in 1 week, but only if you know what you're doing. Now, I stress that because it's very easy to get wrong. It's very easy to go, oh, I can just build this. And I'll give you an example. If you were to pick up, let's say, Codex or Claude Code, the two main tools that are available, if you were to pick up one of those and type into it, program me a snake game, it would probably do a single Python file to produce that snake game in a matter of minutes, and you would have a playable game. Now, that's a very simple and basic thing to do. But if you were to ask it to program an application that required a high level of security, a high level of maintainability, a high level of usability for complex tasks, then you're going to start to get into trouble. What's your observation on that?
So the primary observation is that in the right hands, AI can generate AI monitored coding can generate about a 5 times speed for a senior level developer. And you're seeing this in the industry now, where the companies have a couple of senior developers who have a team of agents working for them, producing 5 times the output that they were producing before. Now, the problems and risks right now, so that the market's been flooded with vibe coding tools. I get ads for Base 44, for Lovable. I think Replic's another one of these tools. And they are great for the amateur wanting to throw together a calorie counting dashboard that they can just use. It solves that personal use problem. I've got an idea. I want to be able to just automate and manage it. Use one of those platforms. Absolutely. And they are amazing for the average individual. But we're talking about the difference between vibe coding and agentic engineering. We're talking about the difference between something that, under stress, will have severe security vulnerabilities, will leak data, will probably crash, versus something that's highly constrained, that is enterprise secure, enterprise scale, but still built at the speed of AI. And that's the shift that we're moving to. But if you do it wrong, and we are seeing examples of many companies doing it wrong. For example, the post that I saw the other day, where the AI agent decided to delete the entire production database for a fairly serious
True
company. True story. And well, one, letting unrestricted AI on a production environment is like rule number 1, never, ever, ever. But in the wrong hands, it can exacerbate a number of the fundamental flaws which large language models have, and we'll talk about that today, because if you get it right, the gains are quite significant.
So we're talking about a situation where, let's say I was a guy sitting in my office. I've got a white collar desk job, as an example. I mean, you could be a trader, you could be anything. It doesn't really matter. But I've got this brilliant idea. I'm going to build this app. It's going to, it's going to make a ton of money. It's going to be amazing. Now, a year ago, I would have had to have called Reinteractive and said, hey, I've got this idea for an app. We would have had many conversations to understand what you're trying to do and where you want to go with it and how you want to produce it and how you want to develop it. And then we would go ahead and we'd build the UX for that, and you'd approve it. And then we'd get you the scope and we'd build the application. And that would be, a serious amount of money to get done, and you'd have your app done at the end of, say, 6 months, deployed, ready for you to sell and market. And that's how it was a year and a half ago. Now, today, if I was that same person and I have this brilliant idea for an app and I want to build it, I can now do that myself with those safeguards that you're talking about. And it's the safeguards that are important. It's the safeguards that will set you apart from the average Joe, so to speak. So when we're talking about the safeguards, we're not talking about things that are going to stop you producing your application or prevent you from doing something amazing. We're talking about the things that are going to allow you to develop something to an enterprise level, to a level that is professional and can be marketed and can be put onto the App Store safely, or Google Play Store, or whatever it might be, or just as a web application. That's really what we're talking about. Is that correct, Kane?
Yeah, that's right. So it's how to get something out to the market that is secure, that's not AI slop, that's not going to turn around and bite you in the proverbial backside because you had no idea how to encrypt a password on the database.
Or that you even should do that.
Yeah, that's right. And so there are, yes, there's a number of, there's certainly key principles which I definitely want to talk about, but there are also quite precise technical guardrails, which we won't have time to get too in depth in today, but that make the ability to generate that secured, well-written code that is not going to turn around and cause you a lawsuit liability because you just accidentally leaked your 5,000 user database and all their password credentials.
Right. So here's the thing. It is possible to produce an application that is secure, that's properly deployed, that is maintainable, and it can be done in a very, very short period of time. And I think we promoted this webinar as being within 48 hours. You could do that maybe in 48 hours, depending on what you're trying to do. Maybe it's going to take you a week, but okay, it can be done pretty fast and you can do it. But there are certain things. So Kane, let's go over some of those. Let's talk about some of those guardrails that you've worked out and you understand and you've seen go wrong. What are some of those things now?
Yeah, so if I can just say, I've been using these guardrails and these principles on a very recent client of ours, where we've basically taken what in the past would have been a probably 12 to 15 week software project, and already we've delivered half of the project. To build half the project took 6 days, and that included the understanding from the client what they wanted, the design of the application, and then the build. So these guardrails.
Blew her
What's
away.
that?
Blew her
Yeah,
away.
totally blew it.
Yeah.
Oh, the speed to market is increased, and the cost of development is converging towards zero, but we'll never get to zero. But it's definitely coming down, it's coming down dramatically. Again, as long as you follow the guardrails, because that apparency of convergence of the price coming downwards, if done incorrectly, it'll be like a parabolic curve. It'll come down and then all of a sudden it will spike up exponentially because of the fact that your code is a minefield of disaster waiting to happen. So, in software development, since the dawn of the IBM ENIAC computers that were building the launch trajectories for the NASA spaceship. So if anyone's seen the movie Hidden Figures about the women who helped launch the first men into space, it's a fascinating movie. But since that day, the most important principle of software and dealing with computers was the idea of garbage in, garbage out. And that principle has been strong up until about 18 months ago. Now, all of a sudden, it seems everyone has forgotten the garbage in, garbage out. The difference we've got with AI is it does have...
Just explain garbage in, garbage out. What does that mean as a fundamental axiom of development? What does that mean?
All right, so if you put in bad data, you feed bad data into the computer. Okay, if you talk about, let's talk about scoping a project as a good idea. If you're dealing with a client and the client only has a vague idea of what they want, and you take that vague description and you feed that into the development team and they build it, and then out the other end comes a vague project where the client turns around and goes, well, that's not what I want. And you've got serious client problems when that occurs. So what's fed in at the beginning affects the downstream. And every piece of garbage, and garbage can be defined as something that's ambiguous, something that's not clear, something that's contradictory, or in the worst case, if you're talking with data, something that has errors in it. So you've got like customer data and somehow you've allowed data to become corrupted. Every bit of that garbage, as it goes downstream through the different processes that it needs to go through, that garbage gets worse and worse and worse till you get the final output, and it's a stream of garbage coming out. And that's why project managers and really good project managers have been so important in the past, because they have been the guardrail against that initial input of garbage, making sure that the project is clearly spec'd, that there is an exact understanding of what the client needs and wants to be delivered. Right. Now, what I see right now, again, with all these vibe coding tools is, and they're great for iterating, like again, Base 44, Replit, Lovable, all these. They're great for building a prototype. They're great for building a little hobby project. They're great to muck around and just try things.
Right, and if you're just going to use it yourself, no problem. Jump in, go for it. Yeah,
it's fine. But if you're just giving it a vague idea, like build me a calorie counting page, for example, like this. I might as well just show. Let's see if I can get this to work.
Nothing like a good demo.
We'll let this run. So here we're going to, are you seeing the Gemini screen here, Errol?
Certainly am.
Okay, good. So this I would constitute as, this is vibe coding. This is no constraints, no real specification of what you want. It's just throw it at the AI and see what you get. That has a place, and it has a place.
You've actually gone far too far there by specifying HTML, CSS, and JavaScript.
Oh, well, that's just so I can get it to output onto there. So Gemini, by the way, has this really good canvas tool, but we can do this. This will take a minute for it to produce. And there it goes. It's writing the code. So what we're going to see is this is the idea of vibe coding. What are we actually going to get out on the other side when this completes? But the thing with AI and garbage in, garbage out is that AI for everything is an accelerant. It speeds up the process of everything. If you think about a pipe, you've got a pipe running water into your home, and if you've got a leak, but you only got a small amount of water going through, it can be very hard to find the leak. You've got to kind of use a lot of tooling and test. But if you flood a lot of water through that, the leaks spring big time. And so what you see with AI agents, if you feed it bad data, you feed it poor specifications, it will exacerbate and it'll spring leaks left, right, and center in a big way. All right, so this is fit fest.
Or jam the pipe up altogether.
Yeah, well, yeah. I mean, that's sort of okay-ish, I suppose. Kind of fun.
I mean, for what did that take? A minute? 2 minutes, maybe?
Yeah, well, it took a minute. And great. And again, for your own personal use, that's really, really good. But if you are building something you want to take to market, that you want it to be professional,
Right, you want
then
people
you
to
need
pay
to.
for.
That's right. So now we've got to get a little more specific. So this is my other screen. So this is one way of designing. It's a level up. There's better ways to do this, but just for, so I've basically taken a screenshot of another application that I thought looked pretty cool. And I'm like, okay, this is how I want to design my application. So I've added this as context to the AI. I haven't given it much yet. So it still is vibe coding, but at least it's a level up of improvement.
Slightly improved, yeah.
And I'll see how well the AI builds this one. I would think it will be better.
Right.
But
well, it will certainly look better.
It was. I hope so. I mean, it's still pretty vibe coded. I give, whenever I'm building, I'm a lot more detailed in the way I specify how the agent. But again, this is a really good way, and things like Google Gemini are a great way to prototype your ideas. But the idea is, so garbage in, garbage out. But to prevent garbage, the idea is you have to ground your agent with context. All right, that's better.
Oh, it looks lovely, yeah.
It's a bit constricted because of the size of my screen at the moment, but it's followed that relatively well.
There's a lot on there that's not going to work too. Like, I don't know how well the actual buttons in interaction works.
Oh, I don't even know if the buttons will work at the moment. Let's see. No. So, but I haven't asked it to. Yeah, but that's the thing. No, nothing actually works at this stage. But the idea is I was using that as a prototype design. So, but this here is the speed of design has gone from like a designer in the past to design what we've got here would take, I would say, several days. Whereas right now, and now I can iterate, and I could say, change the button color from green to, I'm not a good designer, so I'm not very good with colors.
Right, but you're still going to be better than the computer is, because the computer's doing the base average of design. It's taking an average of all of the things it's been trained on and producing this as a result. So any input that you give to it is going to be an improvement on that.
Yeah, well, that's right. Well, I've asked, see, one thing you can't, I've asked it to use something from the color palette. So that's one of the things actually using, he can use agents really well. If you're not a designer, you can say, all right, what's a really good color palette for this kind of presentation? I want the customer to have this kind of, I want my site to be positioned in a certain way. I want it to look a certain way. What's a really good color palette that works for that? And then you can get it to pick colors out of that. So it helps sort of guide you on that front.
Okay.
But, oh, there we go. So now it's changing. So, but the speed of iteration on building out designs is extraordinarily fast. And the way in design to get away from just pure vibe coded AI slop is to ground it with actual data. Now, in this case, I grounded it with a design image. I want it to look like this. And as you move down every step of the development lifecycle, so there's design. Once you get into actually coding as well, you need to ground the agent in technical, the technical articles. So if you're using a particular software language, Ruby on Rails, you've got to give it the Ruby on Rails official documentation. You've got to give it the code that is currently used. What patterns has the code already used? Make sure it's given that as context and grounded in that context so it continues to follow those patterns. So garbage in, garbage out is one thing, but the other big principle of, well, there's two other big principles of AI is the hallucination factor and then the drift factor.
Right.
The hallucination is we'll come back to hallucination. Drift is really important, but not really spoken about a lot. So as you've got an agent workflow, and we'll talk about from the point of view of coding, is that it goes through multiple steps. So we've got this design step, and then it's got to actually code the user interface, and then it's got to build a database, and it's got to secure the database, and it's got to have all the background logic on how the application works. It's a multi-step agentic process.
Right.
Drift is where the agent over time moves away from your original intent. So you fed the agent, the garbage in was like the data in was good. It's not garbage. You spent the time, you worked out what you wanted to build. You built you wrote out a nice specifications document that the agent can read and understand. So that bit's fine. But as over time, agents will tend to drift. And by the time you get to the end of the chain, particularly as you're building lots of features and adding more and more to it, the agent diverges from what you had originally intended.
And that's because it has a context memory of this amount and your application's this amount. It just can't store the whole amount.
Can't store the whole amount. And it's all AI models are probabilistic models, meaning there's no actual real reasoning in AI. It just works on probabilities. But it's been trained on so much human data that it's found these probability patterns. It found that humans, when they do this, mostly do this and this afterwards. There's elements of human nature that are predictable. There's things that happen over and over again. And then same in software, it tends to be that when you build a login page, that you also want a forgot password. And so the agent can through its probability matrix go, okay, login page needs a forgot password. Okay, so that's fine. But the models themselves, again, they are just probabilities. And so what you wanted may not fit that exact probability, the exact line that the agent will follow. And so your intention is going down a certain path, but that may not fit the average of every human being on the planet that the AI has been trained on. And so your idea actually diverges off the average, which I hope it does because you want to build something new. But the AI unguided will just follow its average path. Right. It'll converge to the mean. And so it drifts from your intention.
Right, but correct instructions and correct prompts and correct use of agents will keep it on the path that you want it to go on rather than on its path of least resistance, so to speak.
Yeah, with a lot of, let me stop that, with a lot of guardrails and a lot of work. And this is where agentic engineering comes in as opposed to vibe coding.
Okay, so explain that then. Like I think we've moved into this. So what is agentic and how does that differ from vibe coding?
Right, so we know vibe coding, you throw it at the agent and the AI and let's see what it builds. And anyone who's written or tried to get agents to write blog posts, you may have realized that they all start to sound the same. And in fact, they all start to sound the same so much that there's tooling that can detect AI written articles and blog posts. In fact, I'm sure behind the scenes, Google and their search algorithms are heavily doing this because you see the results of AI blog posts, you get a spike in traffic and then it just dies compared to other organizations that write their own blogs and they get a consistent uptick. So vibe coding is that. Now, the problem with vibe coding, when you're talking about production ready things you want to take to market, is like a blog post, all the websites start to look the same. It's got to the point now where someone who's building a research application for tracking critical neurological illnesses and different, it's like a research tracker for trying different medications and seeing what the effects are. They showed me the app and within 5 seconds I knew they had coded it, vibe coded the whole thing. And
it's like looking for the M dashes.
Yeah, but like looking for the M dashes, it's like looking for the terminology in the blog post that AIs love to use, which is game changer. Let's delve into
why this hits so hard.
Yeah, that's right. So you'll start to see certain design patterns. Like if you ask it to do dark mode, it'll often use this sort of purplish gradient style. So it has this like gradient from one purple, so it can purple to a blue. And I just said to them, hey, you vibe coded this, didn't you? And they said, oh yeah, 100%. I'm like, yeah, I can tell. And that's
It's
a research
distracting.
app, so I'm a bit concerned though about the quality behind it. All right, so vibe coding is great. We've said it's great for prototyping, it's great for your own mini projects. Go, have at it, have fun.
Yeah.
It actually is fun. Agentic engineering is the factor of engineering. It's the control and the guidance of the agents to produce very exact and specific outcomes. And that's building outcomes that are not only matching a very specific design that you want. Same in the old days, how we would design an application before we built it. You'd create this is what the page would look like, and you would have a designer work with the client. So there's that factor. It's making sure that the output that follows your intention, it doesn't diverge. It's making sure that the security is enterprise grade security, not what we are seeing with vibe coding, which is disasters just waiting to happen. And that's agentic engineering. It's not just letting the agent go. It's very specific agent actions with very specific evaluation points, with humans in the loop at very exact and specific points. Done right, that'll give you the 5x speed with the enterprise level of security.
Right. Right. And something that's maintainable as well is very important, because an application, when you write it, it's like a house. Things fall apart. You want to add things onto it. You want to change things. Nothing stays still. So unless you want your application to die after a few months, it has to be maintained. And this is possibly the greatest misunderstood thing amongst people who don't have experience or knowledge of developing. They think once the program is written, it runs forever, and it just doesn't.
No, one of the research points regarding AI coded applications is that for those who are technical and know when you write code, you got to refactor it. So you write it, you get it to work, the code's a bit of a mess, and then you come back and you clean up the code and you put it into different modules and you make it really easy to maintain. So AI let loose by itself will tend to write single files. So it will take what you're trying to build, and maybe in total it's like 2,000 lines of code. It'll try and jam it into a single file. And without exact and precise guidance, it won't automatically refactor. And the longer this goes on, so this is, of course, we always knew this in software development as technical debt. It's you have to pay that debt down at some point. I mean, you have to come back and you have to clean up the code. Now, agents can get away with it a little longer than a human can, because it can consume huge amounts of data much easier than a human. But the problem is it'll also expand how much of this unfactored code there is, to a point, once it gets to a critical mass point, even the agent has trouble fixing it up. And now you've got the human having to go back and spend copious amounts of hours fixing. So a small app will get away with it, but there is an inflection point where the app gets to a certain point, the code is in such a mess. Now the AI agent cannot even build on top of it without introducing an exponential number of bugs. In fact, research is showing that on average, AI coded applications are introducing bugs 2.7 times faster than human development.
Right. And there is a tendency then for the tools, rather than well, they do fix bugs, obviously, but instead of fixing bugs, sometimes it just adds layers of like gaffer tape, maybe is the best way to describe it. Instead of fixing the original bug, just what do we do if that bug exists in the code? Then we go on this path instead. And you never get the actual bug fixed. You just have an apparency that it now works.
Yeah, that's right. It does that all the time. And it's, I know I've been through it. I've been on this particular trying to build out agentic engineering for 3 years. And I've made every mistake. And the only thing I haven't done, because I was at least wise to this, is I haven't let my agents work on production infrastructure, like the actual servers.
Right.
To let one of our staff actually was building some trading bots. They're a good trader, a currency trader, and he violated his own principle of don't let agents touch your production infrastructure. And he just, after the weekend, he just realized that the agent had spun up 10 times the number of servers needed, and his bill was going to go up from like $200 to probably thousands of dollars over a weekend.
That's one of those things, right? There was a bug in the code, and the code slowed down. So how do we solve the problem? Just add more instances. Yeah. Don't worry about the cost, because the money means nothing to the agent.
No, unless it's constrained, and unless you give it guardrails. And this agentic engineering is about guardrails. So, people talk about, we first had prompt engineering, so how to write your prompts. Then you had context engineering, like how to feed, so grounding the agent in the right context, making sure you don't give too much context, because that costs tokens, which costs money depending on what type of model you're using. But now we're getting into agentic guardrails. And it is, in my view, the final step in the evolution to being able to produce, again, enterprise secure, but at the speed of AI. And as these agents, in 5 years from now, it'll be completely shifted again. These guardrails will be pre-built into the models most likely.
Right.
They'll be able to solve a lot of this. But right now, these are the problems we have to solve. And you don't want to wait for 5 years. You want to get something to market now. You can do it 5 times faster than you could before. Let's go. Let's start generating some revenue. Let's not wait until it can do it better. Because then 5 years later, it'll do it better again. And you'll end up waiting forever. So you just go now with the tools, but understand the limitations.
So a basic framework then, Kane, would be you initially write what we call the tickets, which would be concise and compact statements of what you want done, the prompt. But those statements need to be, whilst concise, they need to have enough information, probably more than you would typically give to a human. It would have to have what is the outcome that's expected from that ticket. It would have to have how do you test it? And I mean the person, not the computer. How do you test that ticket to say, yes, that's done? So that would be the first step. And then off to the side, you have the agents. The agents, as those things being built, they check for security, they check for maintainability, they check for, I'm not sure what else. Maybe they're running into test suites as they go, that sort of thing.
Yes.
What else might you have those agents doing as the main agent is writing the code? What are these things off to the side doing?
Right. So the principle that I'm using now is the conductor principle, and it's an orchestration pattern, meaning you've got at the top, you've got a conductor that guides a number of smaller agents.
Right.
So right now for my coding pipeline, I've got the conductor which guides, and then I've got, at this stage, I've got about 19 different sub-agents.
Right. All with a very specific task to do.
Yeah.
Okay.
Very specific, very tailored, very one action, one specialty. So that conductor pattern, which I can't get too in depth into right now because it's quite in depth.
But you might have one that, say, looks after the interface, so the interface stays clean. You have another one that looks after the security. You have another one that looks at like that sort of thing, or another one that looks after deployments.
Well, let me give you a very short rundown of some of the key points of that pipeline.
Okay.
So you've got the scope validator. It takes the scope that's come in and it checks for ambiguities. It checks for conflicting data. Does it conform with what the code already exists is? And it loops. So one of the other key things is the evaluation loop in these agents. They produce something and then it does a validation loop and it validates, and it may ask the user questions, or it may check it grounded against the code base. But that validation loop is the other key to success, because it's, again, there's garbage in, garbage out. Every issue at the beginning of the chain, as it goes through its 16 different sub-agents, will get worse and worse and worse and worse till the output is just complete garbage.
Right.
So you validate the scope. You loop and you loop and you loop until the agent has a confidence score above like 90%. Okay. Then you get into like planning. So it takes the scope and it works out. Again, it's grounded in the existing code. It's grounded in the technical documents of that language, and it creates the implementation plan, and it evaluates, and it loops and loops and loops until it's valid. And then you get into, say, the writing. And I'm not sure if everyone's a coder on here, but one of the things you always want to write with your code is automated tests. So they're tests that actually test that the code you're writing is working, it's not breaking anything else in the application. So you have a test writer agent, and then you have the code writer agent, and then you have the test runner agent, and then you have the text fixer agent, and you're looping through here until it's all completely good. Okay. And then you've got the code refactor agent, and it loops. And then you've got the security review agent, and it loops. And then you've got the agent that checks the original scope. And what we've delivered here, it goes through a checklist, has it delivered everything, and so on and so on. And it's going through a constant loop pattern of validation. And if you don't validate as you go, if you just pass it through a channel from beginning to end, it'll diverge, you'll get hallucinations. There are ways to mitigate. I'm getting close to 100% mitigation on hallucinations. Not quite there. I'm probably at about 98%.
Right, but it's all of these additional checks that get done through the process that mitigate against that.
They're actually the checks that a human would usually do when they're developing. Difference is we can do it faster. The other check as well, for anyone writing code, is there's a tool called Playwright, which can go out and it can actually run a browser. So what happens now in my agent cluster, I call it my tool is called the agent cluster, is it goes through all these steps. And one of those steps is it'll actually go to the website. One, it'll take a screenshot of the website, compare it against the design. So it's looking for divergence against the design. But then it'll actually go and do the things. It'll log in. It'll click the login button.
Into the fields, right.
Yep. And then it'll loop again. And that sends it, and it will find errors, and that'll send it back to the beginning of the coding flow. So in the old days of writing BASIC, back like talking 30 years ago, on
computer language for anyone who doesn't know.
Yeah, it was great. There were a lot of go-to, like you had to write lines of code, and you'd like write go to 10, meaning you'd loop back to line 10, you start again. We're actually at that very basic stage with these AI agents. There's a lot of go-to statements, and this will all get a lot more sophisticated. But there's a lot of looping. Again, there's the evaluation loop, the scope, evaluate it. Is it clear, concise? Are there any ambiguities? But then you've got longer loops. So it goes through the code platform, it gets to the end. You've got Playwright actually checking visually, doing the user testing, and it'll send it right back to the beginning of the coding loop. If it finds anything, it's got to now write more tests. It's got to write the code. It's got to run the test. It's got to check it's secure. It's got to refactor the code. Does the visual check again.
Right.
And it's quite an extensive pattern. But this is how you engineer, and this is agentic engineering and how you write enterprise secure at the speed of AI.
Now, here's, I think, the important part. You're talking from the viewpoint of someone who's educated, has spent decades in the industry to get to the point where you understand how to create this. But we can hand these tools over to someone who doesn't have all of those decades of experience, just knows that they want to build something, and using those tools correctly, educated in them, will be able to build something. Is that correct?
Yeah, I'm actually building that tooling as we speak. I've been literally 16-hour days for the past month building out what I call the agent cluster, or what manages the agentic engineering. And to humble brag a little bit, certainly publicly, what I'm building, there's nothing else in the public domain that does this. There's things that do parts of it, but the entire agentic agent, the entire agentic engineering flow, publicly, there's no one else doing it. I'm sure there's companies that are, and certainly working on it. And I've been doing a huge number of evals, research evals, and comparing it against other tools in the market. And what we're building here at Reinteractive is beating everything else by major percentages. And yeah, we're building something actually I'm really, really proud of, and something that allows, I'm trying to make it as human proof as possible. There's still
accessible.
Points of human, but thank you, accessible is a better term, that anyone can go in and use this tooling with a bit of education, You can't just get thrown into it because then you're just vibe coding again. But with a bit of education and a bit of guidance, can use these tools to build these applications that are secure, that are quality written code, that can be maintained in the future without bringing about future disaster.
Right. So the good news is we're taking this on the road, so to speak. We're doing a series of workshops starting in Melbourne and then moving to Sydney and then elsewhere around the world, I assume. I say assume because I haven't planned anything beyond Sydney yet, but we'll get there. So if you're interested, we do want people to attend these, and we are looking for, I'm going to bring up the slide 1 second here so that you can see exactly where we're going. So you can scan the QR code that's on the screen at the moment. And the first one is in Melbourne, 31st of March to the 1st of April. So it's a 2-day workshop where we're going to be teaching the exact skills that we've been discussing here today. We're going to be showing people exactly how to use these agents, and we're going to give them the tools to be able to do this. So you'll be able to walk away from that workshop building your own application. In fact, at the end of the 2 days, you might even have something close to a done application. So, and we'll even help you with ideas. So I would like you to scan this code, have a look at what it says there, and then sign yourself up for this workshop. I haven't got the dates yet for Sydney, but I'll have those pretty soon, and they'll be on the website. So if you want to scan the code there, and you can have a look when it comes up in Sydney. And we would like everybody to be there. Just before we go, Kane, today, if there's anybody online at the moment that wants to ask a question, please feel free to. If you're listening to this as a recording later, you can just send your questions in the comments, or you can contact me. There'll be a slide at the end in a moment with some contact details, so you can get onto me or Kane and ask your questions. And if you want to go to the workshop, have a look at that QR code. Anything you want to say before we finish, Kane?
No, but the point of the workshop is so that you can actually start to deliver. And in the 2 days, we will help you build something that you can. Now, it might be the beginnings of something, or it might be, if you start small, something that you can actually get out live. So we'll go from the beginning all the way through to how to actually deploy the code, actually how to get it onto, whether it's a website or whether it's onto the App Store or Play Store for Android. Like, we'll take you from the beginning to the end so that you can actually start building your own. So you've got an idea. You've been thinking about, oh, it'd be great if we could just build this. Why hasn't someone built this? Or I want to automate something in my business and I need a tool that will do that. And I don't want to spend $100,000 implementing Salesforce or some other platform. It needs to be customized and tailored to my exact needs in my company. That's the purpose of this workshop, to show you how to do that.
Yeah, absolutely. We're just going to empower people to do it themselves. All right. Well, thank you very much for joining me today, Kane. I hope we answered everybody's questions. I know there's a lot to consume and understand with this subject, but we want you to be able to understand it, hence the workshop, hence the ability for you to just ask your questions directly. So thank you very much for joining us today.
Thanks all.